Hello and welcome to another March Market Math Movie Media production where you get to play the therapist and solve all of math's problems. Today, we're going to be covering 2.5, Solving Systems of Linear Equations on page 78 in your math book. We have a couple of terms that we need to define first, so let's get started. All right, we got two words that we need to go over really fast. A system of linear equations is our first term that we need to know. We know that this is a linear equation, and a linear equation is an equation that when you graph it, it'll be in a straight line, remember? So here's one linear equation. Here's another linear equation. And because we have at least two, we call it a system of linear equations. The other term we have is the solution of a system is an ordered pair that makes both equations true. So an ordered pair that when you plug it in, both of them will be true. I've made both of these up. And if you don't, and this 0, 1 should solve both of these and make them both true. Let's test it out and try. We have 1 goes in for y, 0 goes in for x. 0 plus 1 is indeed 1, so this side is true. And on this side, you put 1 in here, and you put 0 in for x over here. 2 times 0 is 0, leaving us with 1, and you're left with 1 equals 1. So this is a solution to this system of linear equations. What we're going to be doing today is finding this solution for a system of linear equations. So we're going to do it a couple of different ways, and we're going to do it the ways that take a little bit more time first, and then I'm going to get to my preferred way that I'll show you. Here we have a system of linear equations. Here's 1, here's 2, and method number 1 is to create a table. I've taken a picture and I've uploaded it here. This is the very same table that's in your book. You could create a table where you create a row for x values, you create a row for one equation, y equals x minus 5, and you create a third row for your second equation, negative 3x plus 7. And then what you do is you choose different x values and you plug them in and see when the y value matches. So we can see the answer there already, but let's just try it out. Let's plug in 0 for the first one, when we'll get 0 minus 5. And when we do that, y equals a negative 5, right? Which they've put right here. Now, if this is going to be if 0 is part of our solution, then we need to be able to plug it into the second equation, y equals a negative 3 times 0 plus 7. And if this is part of the solution, we need to get negative 5 out here as well. Well, we can see right away that negative 3 times 0 is going to be 0. And then we're going to add 7. And that means that y is going to be equal to 7, which you can see they put here. Well, our y's don't match. So 0 cannot be a solution. They plug in 1. For x in both of these. When you plug in 1 to this one, you'll get 1 minus 5 is a negative 4. And you plug it into this one, you'll get a negative 3 times 1 is a negative 3, but then you add 7, you get 4. So that doesn't match. 2 doesn't match either, negative 3 and 1. But let's look at 3. Let's just work this one out, even though we already see it. Because I want you to be able to understand what we're doing here. This is just basically guess and check at this point. We have y equals, and now we're going to plug a 3 into both of these. So 3 minus 5. So all I've done is I've substituted 3, which is a value that I'm guessing, into the x in our first equation. And then I'm going to solve for y. So when x equals 3, y is equal to 3 minus 5, or negative 2. Okay? Then the second step is I have to plug in 3 to the second equation. So negative 3 times 3 plus 7. So negative 3 times 3 is going to be a negative 9. And I add 7 to that. And what do you know? I get y equals a negative 2. And so this right here is my answer. X has to equal 3. And then y equals a negative 2. And this right here, my friends, is the solution to the system of the equation. 3, negative 2. Now, if you don't like that way of making a table, is a little bit too time consuming for you, there's a second way that you can do this, and you can graph them. By now, we should be pretty good at graphing. So we're going to graph both of these equations, and where they intersect is going to be our solution. So let's graph the first equation. Our y-intercept is 3. So I'm going to do the best that I can here, and I apologize for the inaccuracies. Then our slope is 2 over 1, so we're going to go up 2 over 1, up 2 over 1, up 2 over 1. And we're going to do our best to draw as straight a line as you can. And that's very critical that you draw a straight line as you can, okay? You will do better using pencil and paper than I do using this iPad. The next thing we're going to do is we're going to graph the second equation with our y-intercept at 6, and then our slope is down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And go through there. And the solution is where they intersect each other. So it looks like they intersect each other at the point 1, 5. Now, because I have fat fingers and because I'm not sure if my lines are straight, I'm going to check this. And how I'm going to check this is I'm going to plug in 1 for x and 5 for y and see if both of them are true. So on the first one, on the top equation, I'm going to put in a 5 for y, because it's in the y spot, and I'm going to put a 1 in for x, okay, because this is the x value, and the plus 3. I'm going to see if this turns up true. 2 times 1 is 2, plus 3 is 5, so 5 does equal 5. That is correct. And now let's check it for the bottom equation. Let's plug in 5 for y. Then we have a negative 1, because remember x is 1 and we've got to put the negative, and we have to add 6 to that. Negative 1 plus 6 is 5, and 5 does equal 5, so they both check out, and we know that our answer of 1, 5 is correct. Okay, now here's one for you to try. You can choose what method you want to do. Either try making a table or using a graph, and see if you can find the solution to the system of equations. I'm going to choose graphing this time, just because I want to. And I'm going to graph both of these. I'm going to graph this one in blue, and we'll do this one in green. How about that? So in the blue one, our y-intercept is negative 1, and my slope is up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and I should go in both directions, down 1 to the left 1, down 1 to the left 1, and draw as straight a line as I can. All right, and on the green one, my y-intercept is 3, right there, and my slope is down 1 to the right 1, 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 and I'm going to stop because it looks like that they intersect right there at the point 2, 1. And I just want to double check and make sure, so I'm going to plug those values in to both of these. 1 equals 2 minus 1, that would be 1 equals 1, that checks out. And on the second one, we should have 1 equals a negative 2 plus 3. Negative 2 plus 3, 1 equals 1. So I am correct. The answer is 2, 1. So here's the third and the final way that I prefer, and it takes a little bit of getting used to, I'll admit that. But once you do it, you're going to get it right every single time, and you don't have to mess with drawing a table, and you don't have to mess with graphing. You can just solve it algebraically. So there's a few steps that you're going to have to follow, and you're going to have to practice in order to get it. Say we have a system of equations like we do here. We have y equals negative 5x plus 14, and we have y equals x minus 10. The very first thing that you want to do to solve this algebraically is to solve both equations for the same variable, which is already done for you, isn't it? Both of these equations are solved for y. So step one is already done for us. We want both equations solved for the same variable. It's already done. The second step is to set them equal to one another. So since you have y equals x minus 10, y also equals negative 5x plus 14, you set them equal to one another. Y equals this, and y also equals that. So what we've done is we've set them equal to one another, because they both equal y, right? So they have to equal one another. That's the second step. The third step is we have to solve then for x. So this goes back to just solving an equation with variables on both sides. So what we're going to be doing is solving for x. I'm going to add 5x to this side to get rid of this. I'm going to add 5x to this side. I'm left with x plus 5x gives me 6x minus 10 equals 14. I'm going to add 10 to this side, add 10 to this side, and I get 6x equals 24. And then the last thing that I need to do is to solve for x is, if you said divide by 6, you got it. And we have x equals 4. All right? So I went through that kind of fast. If you need to rewatch it, you can. We're not quite done yet, but I just set the two equations equal to each other and then solved for x. And the last step that I have to do is to plug in what we found x to be into one of the original equations. So remember, x equals 4. You just choose one to put in 4 into. You can put it into this one, or you can put it into the bottom one. It doesn't matter. These are the two that we started with in the very beginning. I'm going to choose the bottom one so I don't have to do the multiplication, save a little bit of work. So y equals, instead of x, x is found to be 4. So 4 minus 10 is a negative 6. So x is 4, and y is negative 6. And that's my answer. If you wanted to check it, you could plug those values into both of these equations to see if they come out equal, and they should. So this method takes a little bit of time to get used to, takes a little bit of practice, but if you put the time into it, you don't have to graph and you don't have to make a table, which is what I like to do. That wraps us up for this particular video, so I'm going to leave you with the joke. The joke is, what did the tomato say to the other tomato during the race? Catch up! All right, guys, thank you for tuning in. I hope you learned something. We'll see you next time, and remember, God loves you.